myself Twinkle Patel from Mahatma Gandhi Institute of Practical Education and Research Center, Navsari. This video lecture is about Message Authentication Code, that is MAC. So in this video lecture, we will discuss what is message authentication, what is the need for message authentication, and then we will discuss the two message authentication technique, that is message encryption and message authentication code. So first of all, we will see what is message authentication. Message authentication is a mechanism or service used to verify the integrity of a message. That is, message authentication assures that the data received are exactly as sent. That is, it contains no modification, insertion, deletion, or replay. Message authentication is a procedure to verify that received message come from the genuine source and have not been altered. Message authentication may also verify the sequencing and the timeline of the message. So, message authentication basically it is a mechanism or service to provide the integrity of a message as well as the it also verify the received message comes from the genuine source and had not been altered. Next, we will see what is the need for message authentication. So, some attacks are possible, which are the reason why we need the message authentication, such as message disclosure, traffic analysis, masquerade, content modification, sequence modification, timing modification, source and destination reputation. For that we require a message authentication. First is disclosure of a message. So, release of the message content to any person not knowing the secret key. First attack is possible. Second attack is traffic analysis attack, in which discovery of the pattern of the traffic between the parties. Traffic analysis reveals information like the frequency and length of the message between the parties. So, next attack is masquerade attack. In masquerade attack, attacker impersonate other person and send the messages. Next possible attack is content modification, in which attacker changes the content of the message. Changes may include insertion, deletion, transposition, and modification. Next is sequence modification. Any modification to a sequence of a message between the two communicating parties, that is insertion, deletion, or reordering of the messages. Next is timing modification, in which delay or replay of the message is possible. Next attack is source repudiation, in which source will deny the transmission of the message. And next is destination repudiation, in which destination will deny the recipient of destination will deny the receipt of the message. So this type of attacks are possible. That's why we need the message authentication. So in which first two, that is disclosure and traffic analysis, which require the message confidentiality, because these two attacks release the message contents. That's why we require the confidentiality. Next masquerade, content modification, sequence modification, and timing modification require the message authentication, and source repudiation and destination repudiation require the message. It will require the message digital signature. So now we will see authentication technique. So first authentication technique is hash function. Hash function maps a message of any length into a fixed length hash value, which serves as a message authenticator. Hash function and its algorithms, which we have discussed in the earlier lectures. Next is message encryption. Message in which the ciphertext of the entire message serves as its authenticator. And the next one is message authentication code. A message authentication code is a function of the message and a secret key that produce a fixed length value and that serve as a authenticator. So in this lecture we will see message encryption and the message authentication code authentication technique. So first we will see message encryption technique. So in which first is symmetric encryption. So in symmetric encryption, message M is transmitted from source A to destination B and message is encrypted using the secret key K, which is shared by the sender and the receiver. Here we get the confidentiality as well as authentication. because here the message is encrypted, we are getting the confidentiality, and this secret key is only known by the source A and destination B. That's why we are also getting the authentication. Next method is next is public key encryption. So in public key encryption, source A uses the public key of B, destination B, and encrypt the message. And on the receiver side, receiver B, only receiver B know its private key and decrypt the message. Here we are only getting the confidentiality and not getting the authentication, because any users because any users could uses the B's public key to encrypt a message and claim that it is a A. So here we are not getting the authentication and we are only getting the confidentiality. So to provide the authentication, A uses its private key to encrypt the message, and then after that, receiver B uses the public key of A to decrypt the message. So here we are getting the authentication as well as the digital signature, because here A uses its private key to encrypt the message. But here we are not getting the confidentiality, but any user who has the public key of A can decrypt the message easily. So to get and confidentiality authentication, both, first of all, we are using the private key of A. So here we are using the private key of A. So here we are getting the authentication, and after that, on that encrypted message, we are using the public key of B, and then send the message. So here we are using the public key of B. So only the user B has its private key. So user B can decrypt that message. So we are also getting the confidentiality here. And after that, using the public key of A, the message is further decrypted and the original message is generated. So this scheme provides the confidentiality as well as authentication. Next, we will see message authentication code. So first of all, message authentication code, that is MAC, is the function of the message and a secret key that produces a fixed length value that serves as a authenticator. In MAC is appended to the message, and this technique assumes that the two communicating parties, that is A and B, shared a common secret key. When A has a message to send to B, it calculates the MAC as a function of the message and the key. So MAC equal to C is applied between K and M. Here C is the MAC function, K is the shared common secret key between the sender and the receiver, and M is the original message, and MAC is the generated MAC code. So the message plus MAC are transmitted to the intended recipient or the receiver. The recipient performs the same calculation on the received message using the same secret key to generate a new MAC, and the received MAC is compared with the calculated MAC. So this is what is message authentication code. Now we will see how message authentication code applied between the sender and the receiver. So first method is, first of all source will calculate the message MAC function on the C is the MAC function using the message and the shared secret key between the sender and receiver. So this message MAC code is generated and appended with the original message and shared to the destination B. So this is a MAC code. Then on the destination side, destination will calculate the MAC code using this message and the shared secret key, and then destination will compare the calculate and receive the MAC code. So here the receiver is assured that the message has not been altered. If an attacker alters the message but does not alter the MAC, then the receiver's calculation of the MAC will differ from the appended or the received MAC. Because the attacker is assumed not to know the secret key, the attacker cannot alter the MAC correspond to the alteration in the message. Here, the receiver is assured that the message is from the genuine sender because no one else knows the secret key other than the sender and the receiver. So no one else could prepare the message with the proper MAC. A MAC function is similar to the encryption. The one difference is that MAC algorithm need not to be reversible as it must be for decryption. Next technique, here in this scheme we are only getting the message authentication. We are not getting the confidentiality. Now we will see the scheme which provide the message authentication as well as confidentiality using the message authentication code, that is MAC. So first of all, first scheme is authentication tied to the plain text, which provide the message authentication as well as confidentiality. In this scheme, the first of all, source A will source A will calculate the MAC using the shared secret key, K1 and the original message. After that, this calculated MAC is appended to the original message and whole message is encrypted using the another shared secret key K2. Here note that the two keys are used, K1 and K2. After that, message is sent to the destination. And on the destination side, first of all, destination D will decrypt the message using the decryption key K2 and then using the key K1 and the message M, calculate the MAC code and compare the calculated code with the appended received code. So this scheme calculate the MAC code on the original message. That's why it is known as the authentication tied to the plain text, because MAC is calculated on the plain text. Another scheme which is used is authentication tied to the ciphertext. In this scheme, first of all, encryption is performed. That is, ciphertext is generated from the plain text using the shared secret key K2, and after that, on the ciphertext, MAC is calculated. So here MAC is calculated on the ciphertext and the key K1, and after that this generated MAC and the encrypted original message, that is the ciphertext, both are appended. So here this is a ciphertext and this is a MAC calculated on the ciphertext. So on the receiver side, first of all, receiver will calculate the MAC using on the ciphertext and then compare the ciphertext with the appended received ciphertext, and also decrypt the message using the shared secret key K2 and get the original message. So here MAC is calculated on the ciphertext. That's why this method is known as the authentication tied to ciphertext. So using these two schemes, we are getting the message authentication as well as confidentiality using the message authentication code. Thank you.